awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Hai, Assalamualaikum. Jom kita revise sambil berehat. Sambil berehat pun, kita boleh belajar tahu dengan tengok handphone. Apa tunggu lagi? Jom kita mula. Okay, sekarang kita akan sambung dengan example number 3. So here we have a 50 kg person stands 1.5 meter away. So here 1.5 meter away from one end of a uniform 6 meter long platform. So here we have 6 meter platform of mass 70 kg. So I will write that the length of the platform should be 6 meter. And the mass of the platform should be 70 kg. Okay, so we consider here is a woman. So find the tensions in the two vertical ropes supporting the platform. Okay, tadi kat atas ni sebut platform, kini typo ni. So kita tukar kepada platform. Okay, so let's draw all the forces exerted on the platform. So ini kita punya platform, kita nak lukis semua force that exerted on the platform. Okay, so the first one should be T1. So the direction should be upward. Okay, ingat ya, direction tension always keluar ataupun outward from the system. So system kita kat sini kita refer kepada platform ini. And then second one should be T2. Ini yang kita nak cari, soalan suruh kita cari. Find the tensions. Okay, kita nak kira T1 and T2. And then here we have a woman. And saya letak ini, sekejap. So saya letak the weight of the woman should be downward. Okay, saya letak weight of the woman. Okay, WW. And another one, at the center of the platform, we need to consider the weight of the platform, WP. Okay, so overall kita ada 4 forces here. So now before we start our calculation, let's choose the pivot point. So antara position of T1 dengan T2, dekat mana you nak consider as pivot point, mana-mana pun boleh. Okay, so I will choose here as the pivot point. Okay, so if here is the pivot point, so the value of torque due to the force that on the pivot, iaitu T1, should be equal to 0 automatically. Okay, ini yang kena ingat. Okay, so kalau kita mulakan dulu dengan equation total Fy. Jadi untuk soalan ni tak ada force in X component, jadi saya tak tulislah total force in X component. So total Fy equal to 0, total torque is equal to 0. So this is the equilibrium system. Okay, so let's start. Total Fy is equal to 0. Okay, saya mulakan dulu dengan total Fy is equal to 0. Boleh tak selesaikan soalan ni? So now let's write the equation of total force in Y component. So we have T1 should be upward. Okay, so positive. Plus T2 also positive, upward direction. Plus negative. Okay, the weight of the woman so should be downward and then negative. So plus negative WP, the weight of the platform. Alright. So apa yang kita nak cari sebenarnya? Kita nak cari ini, T1 and T2. Okay. So the weight of the woman kita ada, the weight of the platform pun kita ada. Tapi problemnya kita tak boleh selesaikan since we have two unknowns. So we need another equation from total torque is equal to 0. So let's start. So total torque is equal to 0. Okay, so saya highlightkan dekat sini. Okay, so total torque is equal to 0. Since the value of torque due to tension 1 is equal to 0, jadi saya tak tulis dalam equation saya. Okay, sama macam sebelum ni. Jadi saya hanya terus tulis torque due to the weight of the woman plus torque due to the weight of the platform plus torque due to the tension T2, second tension, and it's equal to 0. Boleh. Okay. So, sama macam tadi, kalau you rasa you tak tahu direction dia clockwise or anti-clockwise, you nak kira dulu asing-asing, tak ada masalah. Okay. Kita boleh mulakan dulu untuk kira torque. Okay. Torque due to weight of the woman. Okay. Kita mulakan ini dahulu. Okay. So, kita boleh lukis So this is the pivot point. Alright, and this is RW. Okay, so the force of the weight should be downward. Weight of the woman, and it's given 50 kg times 9.81. Okay, so kita boleh kira lah ni, tekan calculator. So kita akan dapat 490.5 Newton. Okay, and then the direction, daripada pivot gerak ke sini, turun ke bawah. So bila patah balik ke pivot point, the direction is clockwise, so it is negative value of torque. Alright, so this is 90 degree. Okay, so RW, distance from the pivot to the point where the weight of the woman exited on the platform. So RW kita adalah 1.5. Daripada gambar ni kita nak tahu kan, kita pilih ini pivot. So this is the position of the woman. So 1.5 meter. Okay, so now we can straightly calculate what is the value of torque due to the weight of the woman. Should be negative RW times the weight of the woman sin 90 degree. Okay, so since this is 90 degree, so sin 90 is equal to 1. So negative 1.5, weight of the woman 490.5. So you kira, you akan dapat torque due to the weight of the woman should be negative 735.75 Newton meter. Okay, so dekat situ kita dah selesai kira torque due to the weight of the woman. And then we proceed to the second force, okay, which is the weight of the platform. Okay, so saya akan tulis dulu. This is about torque, okay, due to the weight of the platform. Okay, saya bulatkan. Sama juga macam tadi, kita ada pivot dekat sini. So daripada pivot kita gerak, okay, and this is WP. Okay, the weight of the platform is given. Okay, mass dia dah bagi, so kita boleh kira lah 70 times 9.81. Okay, cubalah awak kira, tekan calculator kan, practice. You akan dapat 686.7 Newton. Okay, and this is distance daripada pivot ke point di mana force of WP exerted on the platform tadi. Kalau kita tengok pada soalan, the length of the platform is given 6 meter. Okay, so kalau separuh dia, ini mestilah 3 meter kan, 3 meter. Okay, so RP from pivot to WP, RP is equal to 3 meter. Boleh? So 3 meter. Okay, so this is 90 degree. So clockwise or anti-clockwise, so daripada pivot pergi ke sini, turun ke bawah, patah balik, so dia adalah clockwise direction. Okay, jadi sekarang kita bolehlah tulis kita punya equation. Torque due to the weight of the platform should be negative RP WP sin 90 degree. Okay, so negative RP is 3, WP 686.7 Newton. You akan dapat 2060.1 Newton meter. Okay, alright. So the last one, kita nak consider torque due to the second tension T2. Okay, so this is the pivot P. So from pivot, okay, and then this is this is T2. T2 ni kita tak tahu nilai dia berapa, kita nak kira. Okay, and this is RT2. Alright, and it is equal to the length of the platform 6 meter. Daripada pivot gerak ke sini, this is RT2. T2 dekat sini kan, so kita ambil terus pivot ke sini 6 meter. Okay, and then T2 kita tak tahu, kita nak kira, but the direction of torque daripada pivot pergi ke sini, naik atas, patah balik, so dia adalah anti-clockwise direction, so positive value. Okay, so let's substitute torque due to the tension of the string, second tension, should be positive RT2 times T2 sin 90 degree. So sin 90 degree is equal to 1. So saya tak boleh selesaikan sebab saya tak ada pun nilai T2. Saya hanya boleh tinggalkan dalam bentuk 62 sahaja. Boleh? Okay, so now kita boleh selesaikan soalan kita. So kita boleh tulis total torque is equal to 0. Okay, ingat tadi formula kita yang kita dah tulis, total torque is equal to 0. So kita boleh masukkan dekat sini, kita boleh tulis lah. Okay, so torque W, torque due to the weight of the woman, so negative 735.75 plus torque due to the weight of the platform 2000, negative jangan tertinggal, negative 2060.1 plus, okay, torque due to the second tension T2 iaitu 62 and it's equal to 0. Okay, so kita cuba kira. Okay, you selesaikan sebab kita dah ada satu saja unknown dekat sini, T2. So kita boleh cari T2 di mana. T2 akhirnya you akan dapat 466 Newton. Okay, soalan suruh cari find the tensions. Ada dua iaitu T1 dan juga T2. So saya dah dapat T2. So T1 daripada mana saya nak dapat? T1 from total Fy is equal to 0 tadi. Ingat lagi kan? T1 plus T2 minus W, weight of the woman, plus negative weight of the platform equal to 0. So sekarang kita dah ada semua nilai. T2 dah ada, weight of the woman dah ada, weight of the platform pun dah ada. Therefore, T1 is equal to weight of the woman plus weight of the platform minus T2. Okay, so masukkanlah nilai dia. Weight of the woman tadi 490.5 plus weight of the platform 686.7 minus T2 is 466. Okay, akhirnya you akan dapat T1 is equal to 711.2 Newton. Okay, so this is the answer for T1 and T2. So finish example number 3. So let's proceed to example number 4. Alright, example number 4. Let's read the question first. So the mass and the length of the beam. So here we have a beam. Okay, is 20 kg. Okay, and 10 meter respectively. Okay, so the mass of the beam is 20 kg. Okay, so while the length of the beam is 10 meter. Alright, so calculate the tension in the string that support the beam if the beam is in equilibrium. So now we want to find T here. So if we draw all the forces on the beam, we have tension here and then we have the weight here, which is mg, 15 times 9.81. Okay, kalau kat sini kita dah boleh tulis lah macam tu. Alright, and then at the center of the beam we need to consider, okay, the weight. Okay, the weight of the beam. Okay, mass tadi dia dah bagi, so 20 times 9.81. Okay, so weight of the beam tu kita dah boleh kira lah nanti. Okay, iaitu kita boleh kira siap-siap 196.2 Newton. Boleh. And this one should be equal to weight of the mass. Ini saya letak Wm. Weight of the mass is equal to 147. 147.15 Newton. Okay. So now, jangan lupa soalan B, dia suruh kita kira calculate the magnitude and direction of the force of the hinge on the beam. Iaitu merujuk kepada reaction force of the hinge on the beam. Okay, kat mana dia punya reaction force tu? Okay, kita boleh letak S ataupun R. Ada buku letak S iaitu supporting force. Okay, you mungkin akan guna R iaitu reaction force. So it's up to you. Okay, so dia dekat sini. Okay, saya tak tahu direction dia ke mana. Saya hanya letak saja S. Kita boleh kira dia punya angle of direction. Okay, due to the horizontal. Okay, so kenapa ada resultant reaction force? Okay, this is due to Sx and Sy. Okay, ni tak nampak ni kan Sy. Okay, so saya ada terima lah soalan Sx dengan Sy ni kenapa ada kan? What is the relationship antara S ni, kenapa tiba-tiba ada? So dia adalah reaction force, resultant reaction force. Okay, so Sx is due to the normal force. Kan antara dinding warna biru tu dengan beam tu, kita tahu kita akan ada normal force. Saya nak tulis kat sini. Contohlah. Okay, normal force here, N. And at this point, okay, we have another force that support the beam. Kan, kalau tak, beam tu akan jatuh ke bawah, betul tak? So, kita kena consider, so there is a frictional force which is upward direction. Okay, di mana frictional force ini bertindak sebagai supporting force kepada sistem tersebut. Jadi, normal force dengan F ni, kita tak tulis N dan F. So, kita tulis sebagai SX, which is the horizontal supporting force, SX. Okay, ini SY, dia adalah vertical supporting force, SY. And kalau kita nak kira what is the resultant supporting force or what is the resultant reaction force of the hinge on the beam, kita kena kira S. Di mana S is equal to, kita boleh tulis lah, okay, resultant force S is equal to SX squared plus SY squared. Jadi soalan B suruh kita cari, okay, magnitude and direction. Magnitude and direction. So angle kita kena kira, and then the magnitude of S. Okay, which is force of the hinge on the beam. You nak guna S boleh, you nak guna reaction force R pun boleh, tak ada masalah. Boleh? Okey. Jadi sekarang kita nak jawab soalan yang pertama dahulu. Calculate tension in the string that support the beam. So I want to find the value of T. Okay? So remember, this is the pivot point. Okay? So kalau sini pivot point, torque due to the supporting force, takkanlah dia yang nak support beam, dia pula ada turning effect kan? So torque S should be equal to 0. Okay, so now let's proceed. Okay, saya sambung dekat sini. So let's proceed here. So we have total torque is equal to 0 since the system is equilibrium. The beam is in equilibrium. Okay, so kita ada 3 forces here. WB, WM dan juga T. Jadi saya akan tulis torque WB plus torque tension plus torque due to the weight of the mass equal to 0. Boleh? Okay. So, look at here. Sama juga, kita nak kira satu-satu ke? Boleh, kita kira satu-satu. Kita boleh kira dulu what is torque due to the weight of the beam. Contohnya kan, awak nak buat satu-satu. Tak ada masalah. Okay. So, nak tentukan direction clockwise or anti-clockwise. So, this is the pivot point. So, gerak ke sini. So, this is RB. Okay, separuh panjang beam ini adalah 5 meter lah. So here should be RB equal to 5 meter and this is WB. So angle dekat sini berapa? Angle dekat sini berapa persoalannya? Okay, so sekarang kalau kita nak kira angle dekat situ, okay, sebenarnya kita boleh tahulah, soalan dah bagi kita hint. Hint tu apa dia? So kalau angle dekat sini adalah 30 degree, so here is 30 degree. Okay, so here is 30 degree. So dekat sini pun angle dia adalah 30 degree. Kan? Here should be 30 degree. Angle between the beam to the horizontal line should be 30 degree. Kan? Okay, so kalau sini 30 degree, so kalau kita extend the triangle, alright, so here should be 60 degree. Here should be 60 degree. So kalau saya lukis, so this is the pivot. Okay, pergi ke sini, iaitu separuh panjang beam, iaitu 5 meter, and then straightly downward. Oh, sorry. Okay, and then straightly downward. WB, and it's equal to 196.2 Newton. So the angle here should be 60 degree. Okay, so clockwise ke anti-clockwise ni? Obviously, dia adalah clockwise direction, so dia adalah negative value. Okay, so kita boleh terus tulis torque due to the weight of the beam should be negative RB times WB sin 60 degree. So the angle between RB and WB is 60 degree. Okay, so kita boleh terus masukkan dalam kita punya calculation where RB is 5, WB kita dah kira tadi sin 60 degree, So it is equal to negative 849.57 Newton meter. Okay, so kita dah selesai yang itu. Okay, let's say kita nak proceed untuk kira torque due to tension T. Okay, so saya tulis, okay, saya nak tulis dulu torque due to the tension T. Look at the position. So from the pivot to this position, kita tak tahu kan, daripada sini ke sini berapa panjang dia. Itu yang menjadi persoalannya. Tetapi jangan lupa, soalan bagi kita from the pivot to this point is 4 meter. Jadi untuk tidak mengelirukan awak, kita lukislah dulu kita punya triangle. Okay, so ini kita punya pivot. Okay, so this is T, tension. Kan? So kat sini soalan dah bagi 4 meter. And this is also given 30 degree. Okay, so from the pivot here, so saya letakkan distance daripada pivot ke point ini sebagai RT. So RT ni kita tak tahu. Okay, trik dekat situ, RT kita tak tahu, tapi this is a triangle, so kita boleh kira. Okay, so we can use sine 30 degree is equal to opposite 4 meter over hypotenuse, which is RT. Therefore, RT is equal to 4 over sine 30 degree. So, you akan dapat 8 meter. So, RT kita akan dapat 8 meter. Okay. So, this is anti-clockwise direction daripada pivot ke sini. And then, direction of T. So, dia nak patah balik ke pivot. So, dia adalah anti-clockwise direction. So, the value should be positive. So, torque due to the tension. So, positive RT times the tension T sine. The angle between RT dengan T tadi adalah 30 degree. Okay. So, dah akan jadi positive 8. So, T kita tak tahu. Kita nak kira sine 30 degree. So, saya selesaikan dulu 8 times sine 30 degree. Saya nak simplify. Saya tak nak panjang-panjang macam tu. So, positive 4T. Saya biarkan dulu. Kita tak boleh selesaikan. And then we proceed to the third force, which is the weight of the mass. Okay. Kita kira dululah torque dia. So, torque due to the weight of the mass. Okay. Kalau kita lukis, this is the pivot point. This is the length of the beam. So, dekat hujungnya tu kita ada weight exerted at this point. The weight of the mass is 147.15 Newton. Okay. And angle dekat sini berapa? Kalau dekat sini tadi 60 degree, samalah sini pun mesti 60 degree. Okay. This should be 60. Boleh? Okay. And then from pivot point ke point that we exit the weight of the mass, nak letak apa RW lah. RM. Kan? RM. Tadi RB, ni RM. Okay. Maknanya daripada pivot kepada mass M ni tadi, iaitu bersamaan dengan length of the beam, which is 10 meter. Boleh? Okay. So the direction daripada pivot pergi ke sini, turun bawah, patah balik pivot. So clockwise direction. So negative. Alright, now let's write the equation. Torque due to the weight of the mass is equal to negative. Negative jangan lupa tertinggal nanti. Jangan lupa tulis. Okay. So RM times WM. Sin. Tengok senang nak tengok. P pergi ke sini. Angle between RM and WM is 60 degree. Okay. So, you masukkanlah nilai dia. Berapa tu? Negative RM is 10. WM is 147.15. Sin 60 degree. Okay. Tak muat saya letak kat sebelah ni. Therefore, torque due to WM is equal to negative. Tekan calculator. 1274. 1274.36 Newton meter. Okay, jadi sekarang saya akan kira dekat sini pula. Okay, Tak muat ni, saya bagikan kat sini. Okay. Okay, so total torque is equal to 0 tadi. This one. Okay. So, kita boleh kira lah terus. Okay, so total torque is equal to 0. So, kita nak kira tension in the string. Kita ada torque WB. So, substitute terus negative 849.57 plus torque due tension 4T plus, okay, tak muat ni, saya akan gerak sikit. Okay, plus torque due to the weight of the mass, iaitu negative 1274.36 equal to 0. So, kalau tengok pada equation ni, sekarang kita boleh cari T. Dekat sini ada satu saja unknown, iaitu T, tension kita. So, kita boleh kira lah. Capital T kita akan dapat berapa? Awak tekan kalkulator, you akan dapat jawapan 531 Newton. Unit jangan tertinggal. Okay? So, ini settle untuk soalan B. Ni kita buat soalan B. Soalan A. Soalan A. Jadi, soalan B. Okay, kita baca soalan B. Calculate the magnitude and direction of the force, okay, of the hinge on the beam. So, kita nak kira S. Kan? Tapi sebelum kita kira S, kan? S tadi kan macam ni. Kita kena kira dululah. Nilai SX dia berapa. Dan nilai SY dia berapa. Boleh? Okay. So, macam mana kita nak kira? Okay. Tengok pada free body diagram kita. Kita patah balik kepada free body diagram kita ni. Okay, kita boleh tulislah. Total Fx is equal to 0. Kan? Total Fx is equal to 0. So, ada dua saja force in X component. Iaitu Sx dan T. T ke kiri, Sx ke kanan. And then, total Fy also equal to 0. So, we have 1, 2, 3. 3 forces in Y component. So, kita boleh buat Sy plus negative WB plus negative WM is equal to 0. Okay. So, kita nak kira lah berapa supporting force. Berapa Sx. Okay. Nilai Sx yang untuk support all the forces. Okay. In X component. So, kita boleh tulis dulu kejap. Total Fx equal to 0. Okay. Jadi, screen ni limited. Okay, kalau awak salin, awak tengok balik free body diagram. Kita hanya ada dua saja force in X component. Iaitu Sx to the right plus negative T. Negative sebab direction of T is to the left. Okay. So, it is in equilibrium sebab itu equal to 0. So, Sx you akan dapat equal to T. And T kita dah tahu tadi 531 Newton. Okay. And then total Fy equal to 0. Kita buat perkara yang sama. Refer kepada free body diagram yang kita dah lukis tadi. We have 3 forces. Sy, direction dia upward, plus the weight of the beam, which is downward, plus the weight of the mass, which is also downward direction. So, Sy should be WB plus WM. Boleh So, kita kira lah Sy itu berapa. Tadi kita dah tahu dah WB tu adalah 196.2 Newton plus 147.15. So, Sy you akan dapat 343.35 Newton. So, let's calculate what is the resultant. Kita nak kira magnitude dulu Resultant force of the hinge on the beam ataupun reaction force ataupun supporting force. Okay. So, saya akan masukkan nilai dia. 531 squared plus 343.35 squared. Okay. And S you akan dapat 632.34 Newton. Okay. So, ini dia punya magnitude. And how about the direction? Theta. Okay. Inverse tangent Sy over Sx. Okay, masukkanlah nilai ni tadi. Okay, awak buat So, theta you akan dapat 32.9 degree. Okay, so 32.9 degree above above positive x-axis. Kan? So, kalau kita tengok dekat kita punya diagram, okay, kita tahulah so the angle 32.9 degree tu ini. Yang saya buat ni. Okay, angle dia adalah 32.9 degree. Okay, so the direction is 32.9 degree above positive x-axis, and the magnitude of the force of the hinge on the beam, atau nama lain dia adalah supporting force ataupun reaction force, okay, on the hinge adalah 632.34 Newton yang kita dah kira tadi kat sini. Okay, so finish example number 4. So let's proceed to example number 5.